In today's video, we're going to take a look at moments, which can explain things like why a longer spanner is easier to use than a short spanner, and how two people with different weights can balance on a seesaw. First though, we need to look at what exactly a moment is. We can describe a moment as the rotational or turning effect of a force. For example, if we had a spanner that we were using to tighten a nut, and we applied a force downwards at the end of the spanner, then instead of the whole spanner moving downwards, it would just turn around this central point, which we call the pivot. And it's this turning effect that we refer to as the moment. In order to work out the size of a moment, we need to use this equation here, which says that the moment is equal to the force that's applied times distance. And importantly, this is the perpendicular distance between the pivot and the place where the force is being applied. So to get the biggest moment possible, you should apply a big force far away from the pivot. Now, the fact that we use perpendicular distance is actually really important. Perpendicular means at right angles. So you have to measure the distance at a right angle to the direction of the force, which in our example here is basically the whole length of the spanner. However, if we applied the force at a weird angle, like this instead, then our perpendicular distance would be much smaller, which means that the moment this creates would also be much smaller. Let's try to calculate our own moment. Imagine that you apply an 80 Newton perpendicular force to a spanner 20 centimeters from the pivot. What moment do you generate? First, we need to check our units and change the 20 centimeters into meters, giving us 0.2 meters. Then we can just multiply this 0.2 meters by 80 newtons to get our answer of 16 Newton meters. Now, what if you wanted to generate that same moment of 16 Newton meters, but by applying a force 0.1 meters from the pivot instead? To calculate the force required, we'd have to rearrange our equation to get moment over distance equals force. Then we just plug in our moment of 16 Newton meters and our distance of 0.1 meters, and would find that the required force is 100